let's discuss the domain of the square root of x is 0 to infinity, all right? Only positive numbers and 0, all right? So the domain of f of x is, you can either write it as, bless you, x is greater than or equal to 0, or you can use interval notation from 0 to infinity, and you can't see it, thank you. 0 gets a bracket, okay, because you can take the square root of 0. 0 gets a bracket because you can take the square root of 0. Infinity always gets a parenthesis because infinity is not a specific number. It's just the concept of the biggest number you can come up with. All right, how about g of x being the cube root of x? What's its domain? All real numbers or negative infinity to positive infinity. Those both that say the same thing. Okay? Those both say the same thing. We finally ran into a function here that didn't have a domain of all real numbers. Okay? Most of the ones we've dealt with so far have. Polynomial functions, exponential functions. Logarithmic didn't, because we can't take the log of a negative number. Same thing here. We can't take the square root of a negative number, but we can take the cube root of a negative number. All right, so how about the range for f of x? What's our range? Same thing, 0 to infinity, but this time we're talking about the y values. So y is greater than 0 or from 0 to infinity. Okay, how about g of x? All real numbers. I don't know why I want to keep on putting an equal sign. Okay, it is all real numbers. Now, it's very, very slow, but it will eventually hit them all. And what I mean by it's slow is this function looks kind of like this. So it kind of looks like it's leveling off, but it does continue to increase over to the right and decrease on the left side. Okay? Yes. Yes, it is a bracket. It doesn't look very much like one, does it? It's a very curved bracket. There we go. Make that a little bit more clear. Okay, how about x and y intercepts? Okay, so both of them go through the origin. Okay, both of them, well, the square root of x starts at the origin, and the cube root of x passes through the origin. I'm not sure why I have such a big spot here for that, but I guess it was just to remind you that when you're finding the x-intercept, you set the equation equal to 0, and when you're finding the y-intercept, you plug in 0 every single time. Okay, it doesn't matter what kind of function you're talking about. If I ask you what's the x-intercept, you set that equation equal to 0 and see if you can solve it for x. If I ask you for the y-intercept, you plug in 0, see if you can get out an answer for y. You can't always, but in this case, both of those are 0, 0. Okay, intervals of increasing and decreasing. So the square root function, f of x, the square root of x, is it increasing or decreasing? Increasing, okay? It is increasing for its entire domain. So from negative, not in negative infinity, from 0, and we don't put a bracket because at 0 it's not really technically increasing. So from 0 to infinity, it is increasing. It never changes. So we have no extrema. I'm going to go ahead and put that on f of x. No extrema. All right. For the cube root function, what is it doing from left to right? It's still increasing. Okay. It never changes. It is always increasing. But for this one, we put from negative infinity to positive infinity because that's its domain. So it also has no extrema because there's no change. Okay, last thing we need to talk about is its end behavior. F of x only has one end that we can talk about, so to speak, because it starts at the origin. So we only have to worry about when x goes to positive infinity, where are our y values headed? Positive infinity as well. With g of x, as our x's are going to negative infinity, the left side, where are the y values going? Negative infinity, and then For positive infinity, the y values are going to positive infinity. Okay, that's the end behavior for these two functions. These are kind of things that you should know without your calculator. Okay, you need to know, what does the square root of x look like? It starts at the origin and it looks like this. I need to know that the cube root of x goes through the origin and looks like this, kind of like our cube root function on its side, which makes sense because they're inverses, right? Inverses have that symmetry property. I know we haven't talked about inverses, but you did talk about them in Math 3. Okay, so that was just our introduction to radical functions. We're going to take a step back and we're going to look at operations with radical expressions. Okay, so we're going to start with simplifying. Okay, we're going to start with simplifying. You've been doing this for a while, so some of you have this down pat, some of you still need to work on it. Simplifying radical expressions. The goal is that you want to express that number that's under the square root as the product of a perfect square and another number, and you want the biggest perfect square. So for 216, I believe that 216 is divisible by 36. Let's check it. It is. All right, so for these first few problems, I'm going to write it out, and then I'm going to start skipping steps. Okay, so 216 is equal to 36 times 6. Technically, what we're looking at here is the square root of 36 times the square root of 6. The square root of 36 is 6, and 6 is not a perfect square. Don't say that you can't take the square root of 6, and really I'm talking to myself because I'm really bad to phrase it that way. We can take the square root of 6. It's just not a perfect square. It's not going to give us a whole number, okay? So 6 square roots of 6 is the correct answer. Guess what? You can check it, all right? Check it. Type in the square root of 216. Look at that decimal. Type in 6 square root of 6. Make sure it's the same decimal, okay? You may not have the fully simplified version, but at least it is an equivalent version, okay? All right. What if there's a coefficient in front? Okay, well, we just leave it there until we simplify the square root. So we leave the negative 7. 196, is that 16? Nope. 36? Nope. It's what? Oh yeah, I do this every single time I do this problem. 196 is a perfect square. That should usually be something that you check. Yeah, when you first do the problem. The square root of 196 is 14. Check and see if it's a perfect square first. It's just not on our list, so I forget about it because it's our list. I only have memorized through, well, I know that 13 squared is 169, but I did not have memorized that 14 squared is 196. So the reason why I had this example was because I wanted to point out when you do that, then you multiply those two numbers. Okay, so this is equal to negative 98. And the nice thing is you can just type this one in and it will give you negative 98. Okay, so no question there. All right, now you may not have had to deal with this before, with a variable under there. Have you done the ones with variables? Maybe, yes, no? I don't think we did. Maybe we did, I can't remember. Well, we're going to do them now. So, all right. Number part first. 80. Isn't that 16 times 5? Yeah, 16 times 5. 16 times 5 is 80. I'm trying to decide how I want to write this. Okay. I'm going to write x to the 4th as x squared times x squared. Okay. Just to give you a different perspective, because this will make more sense to some people, and then the other way I'm going to explain it will make more sense to other people. All right, so the square root of 16 is 4, so that comes out. 5 is not a perfect square, so it stays under. The square root of x squared is x, and the square root of x squared is x. So this final answer is 4 times x squared, square root of 5. Now, you technically don't have to do that to simplify the variable part. Okay, technically you can just divide the exponent by 2 because we're taking the square root, so 4 divided by 2 is going to give us the 2. But the reason why I write it like that is to help you with something like D. Okay, 252, I don't know, maybe 36. Whew, lucky guess. Okay, so 252 is 36 times 7. I'm going to write k cubed as k squared times k to the first, right? Because when you multiply bases, you add the exponents. So k squared times k to the first is k cubed. All right, so when we're simplifying this, the square root of 36 is 6. 7 is not a perfect square, so it stays under. Square root of k squared is k. So left under there, we have 7k. When the exponent is less than the root, this is the square root, when the exponent is less than the root, you got to leave it under there. Okay? You could also look at it as 2 will go into 3 once with 1 left over. So 1 comes out and 1 stays under. Okay, however you want to look at it there, as long as you can get to the conclusion, 6k times the square root of 7k, I really don't care. Okay, let's do one more here. Leave the negative 6 in front. 45 is 9 times 5. I'm not going to rewrite these because they're even numbers, so I'm just going to evaluate them as I go. Okay, the square root of 9 is 3. 5 is not a perfect square, so it stays under. Square root of x squared is x. The square root of y to the 4th. Divide 4 by 2 and get 2. So what did I leave under there? You may want to, like, if you have to leave something under there, you may want to, like, circle it. It might help you out when you're going back to figure out what should and should not be under there. Okay? So then the only thing left to do is multiply the negative 6 and the 3. So negative 18xy squared, square root of 5.